Hello everyone, welcome to class. Today we are looking at waves. Waves. Basically, waves is produced whenever there is vibration. Sound waves, when there is vibration. And purely, we can say that waves is actually process to which energy is being transferred, okay? From the source to other, surrounding, as case may be. But basically, for this class, we want to look at the two types of waves, and that is longitudinal wave and transverse wave. All right, so I'll just explain the fundamentals of the two waves to us. Let's start with longitudinal wave. When you talk about longitudinal wave, we are talking about a wave in which the particles of vibration travel parallel to the direction of propagation. What am I saying? Let's look at this. Now, if I have a waveform, now if this is direction at which the wave is traveling, what I mean is this. This is a waveform, okay? Of course, we are supposed to know that every wave has its parts. What I mean is, we have crest at the top, we have the trough, and we also have distance between this line AB is what is called the rest line. Distance between the rest line and the crest is the amplitude. All right? Now, amplitude. Now, quickly, if wave is traveling this way, the particle for the wave is traveling parallel direction of propagation. Is traveling this way and is vibrating. So this direction of propagation of vibration of the particle, and this direction of the wave's propagation. So whenever a wave travels, the particle travel parallel to the direction of propagation, we say it's a longitudinal wave. All right. And of course, we should also know that for a wave, the equation is F equal to lambda. V equals to F lambda. Sorry. Now, on the other hand, for transverse waves, the particle travel at angle 90, perpendicular to the direction of propagation. The similar waveform that I drew for that one, look at it. Of course, if I have this wave, now, in this case, the particle is vibrating up, down at every point in time, and the wave is traveling this way. Traveling along the direction, but the particle is vibrating at angle 90 so that to the direction, so that if I bring this down, you are going to have this as 90 degrees. So whenever a waveform travels, the particle travels in the waveform at angle 90 direction of propagation, we say it's a transverse wave. And example of these two waves, for longitudinal wave, we have sound wave. Sound wave being the example. For this other one, we have all the members of EM spectrum. I'm talking about radio wave. Radio wave is an example. We also have infrared as another example. We also have even water wave. Water wave is also an example. So many examples for transverse wave. And like I said, for longitudinal wave, this same equation is also true for this. V equals to F lambda. And quickly, well, it's good to also look at when you say V, for both of them, V is the speed at which wave is traveling in meters per second. F is a frequency. And we talk about lambda being the wavelength. And for every wave, wavelength is simply the distance between any two similar points, all right, on the wave. For example, between point A and point B is a wavelength. Between this crest and this crest is also a wavelength, and so on and so forth. So, as a matter of fact, that is exactly what we call wavelength. And of course, wavelength is in meters, which is the distance, the unit of distance. So, basically, that's all we have for today. Thank you very much. Have a nice day. Bye for now.